Water is a really important substance in biology and in our lives, and we sometimes take it for granted. It's all around us and we use it for so many things. In fact, one of the reasons it's so important in biology is because we're made up of so much water, about 70%. But when you look at yourself, you see a solid body, and water is liquid. So what's going on here? Well, you're made of cells, just like all living things, and inside of cells is where you find a lot of water. There's also water, and about 60% of our blood is also made of water. All of the chemical reactions that happen in your body take place in water. So in a discussion of why chemistry is important to life, water is a good place to start. Just a little review from the last lecture. Water is a polar molecule, which means that even though it has an overall charge of 0 or neutral, each end has a slight charge because the electrons shared in a covalent bond are not shared evenly. The electrons spend more time around the oxygen atom. So what makes oxygen so greedy? It has 8 protons, which all have a positive charge, and hydrogen has only 1 proton. So the electrons are more attracted to the nucleus of the oxygen atom than they are to the nucleus of a hydrogen atom. Having these oppositely charged ends allows water molecules to form bonds with other water molecules. In the last lecture, you learned that bonds between charged molecules are called van der Waals forces, but water forms a special kind of van der Waals force with other molecules. They form hydrogen bonds. They're called hydrogen bonds because they involve the electron of a hydrogen atom being shared with some other atom. In this case, it's oxygen. Hydrogen has only 1 electron, so when it shares it, that electron is always more attracted to the other atom involved in the covalent bond. Anything else it bonds with has more than 1 electron. It can bind with other hydrogen atoms, but when it does that, it doesn't form a polar bond because the electrons are shared evenly between the 2 hydrogen atoms. So when it shares its electrons unevenly, the electrons spend more time around the other nucleus. In fact, its electrons spend so much more time away from the nucleus than any other atom, and that makes hydrogen bonds more strong than any other van der Waals force. So that's why they get their own name. The bottom line is that hydrogen bonds, even though they're weaker than both ionic and covalent bonds, they're the strongest van der Waals force. Because water is able to bind with other water molecules fairly strongly, it causes water to behave in some interesting ways. First of all, water is able to stick to itself. This property of water is called cohesion, and that's why water tends to form beads or droplets. It's also what causes surface tension, which allows bugs to walk on the surface of water. One of the bad sides of this property can be seen during summertime, usually around swimming pools with diving boards, and I found it more with boys and young men. Yep, I'm talking about the belly flop. It hurts so bad and makes the belly so red because you need to break millions, billions, maybe even trillions of hydrogen bonds. Water also sticks to other substances. This property of water is called cohesion. If you look very carefully at a thin column of water, like in a graduated cylinder, you'll notice water near the edges of the container seem to creep up the sides, like you see in the picture with the straw. Water is hydrogen bonding to the straw. It also hydrogen bonds to the sides of a graduated cylinder, which is why you should read the volume at the lowest point, or the meniscus. Cohesion is also why substances look darker when they're wet. The water hydrogen bonds to the substance, and the water attracts sunlight, so the substance absorbs more sunlight and looks darker. Like if you think about it, when you wear black clothes or sit in a black car on a hot day, it's really hot because it's absorbing more sunlight. One of the really cool things about adhesion and cohesion is that water can crawl up it can almost crawl up tiny little tubes. So inside of plants, there are tiny little tubes that go up through the roots, up the stems, and into the leaves. In the stems, these tubes are called xylem, and they allow water to move from the roots up to the leaves of a plant without using any energy or any sort of other outside transport system. What a great deal for the plants! Speaking of heat, water is able to absorb a lot of energy without changing temperature. Sometimes the words heat and energy get a little confused, especially in everyday language, so here's the difference. Heat is the sensation you feel because molecules have a lot of energy. They're moving around a lot. So, if you give water a little bit of energy, it's not enough to make the molecules move around. The energy is absorbed by those water molecules. But if you give water a lot of energy, you'll break the hydrogen bonds between the water molecules, which allows those water molecules to move around more, and then you feel the hotness. If you've ever cooked pasta or macaroni and cheese, it takes a little while after you've turned on the stove for the water to boil. That's because in order for the water to boil, you need to break all the hydrogen bonds. So why is this property of water important to life? Well, if it takes a lot of energy to change the temperature of water, and we're made up of 70% water, that makes it harder to change the temperature of our bodies. And remember, all living things are trying to maintain a stable internal environment, or homeostasis.